So I received a question about this problem from the homework. Now this is technically number 41 from the book. You can see it over here. So I got it from the study plan number 41 right there, which means if you opened up the book on either the physical book, section 3.2's homework, you'd go to number 41, you'd find this problem. Or you could open it up online, number 41, it'd be the same problem. Okay, so it says recall that, oh, and I'm not going to do the actual problem, I'm going to do the example, but it's going to work very, very similarly. All right, recall that blocking refers to the idea that the variability in a variable can be reduced by segmenting the data by some other variable. The data in the accompanying table represent the recumbent length in centimeters of a sample of 10 males and 10 females who are 40 months of age. Complete parts A through D. All right, so a couple of things. You're looking at 10 boys and 10 girls, and recumbent length is basically their height, but lying down, right? So they lay down and you measure them from head to toe. That's the recumbent length. And the blocking thing is talking about something we talked about in chapter 1, which is namely, if you segment your population, what you're going to do is reduce your overall standard deviation, your variability. Now here's why. Well, think about it in terms of like a high school class. If you're looking at heights of high schoolers, if you look at freshmen, sophomores, juniors, seniors, it's going to have a lot of variability because the seniors are taller generally, the freshmen are shorter, right? And you're going to have a huge spread. But if you look at each group individually, just the freshmen, just the sophomores, just the juniors, and so on, you have a lot less spread in each group individually, right? Because, you know, they're all very similar, they're homogeneous, okay? That's what we're going to show you, but with males and females. Okay, so the first thing they want us to do is determine the standard deviation for all 20 links. And they give us this big, long rigmarole, which you don't have to do any of. What you do is you click on the table. Right there, there's a little icon. And you can see the data sets. And you want to click up here. Now, we're going to use the copy to clipboard. If it doesn't work right, that's what these other four are for. These are kind of the more computer science, computer programming way to think about these things for copying. So for the most part, you can ignore them. But if ever a copy to the clipboard doesn't work, then you can try one of these other ones or all of them and see which one works for you. And actually, I don't open in Statcrunch hardly ever. I choose to copy to the clipboard and then I can paste from there, right? So I'm going to paste. You can either click on this icon up here or I can hit Control V. There we go. Okay. So, and then if I want Statcrunch, what I do and what you should do is have it open in its own window. I have it right here. I just go to www.statcrunch.com. There we go. And then I use my same login and password that I use for my math lab because my math lab pays for your access. They make it so that you have free access to Statcrunch for the duration of the course. So you might as well use it. So I would just click on this variable one thing here and paste. And there you go, same thing. So copy and paste into Excel, and if you want to paste from there to Statcrunch, so be it. The other option is to open it in Statcrunch itself. Let me click on that. So if you do that, it opens it in this little mini window, and that can be problematic. You can see it hangs for me. It's taking a while, and that sometimes happens. Yes, run it, etc. If you do that and then copy and then go back to your regular window and paste, that'll work too. Okay, but you generally want, and this is true for this whole course, you always want Statcrunch kind of open on its own, in its own little tab that you can swing around and do whatever you want with. You don't want to open it in here. This is not a good scene to open it up in my math lab itself, because it opens it up inside this thing, and the two programs can kind of fight with each other, and sometimes Statcrunch won't work that way. So open it up in its own window and keep it in its own window. Now I'm going to show you both Excel and Statcrunch for this problem actually. All right, so they want you to find standard deviation for all this stuff. Now you have to know, hey, this was a sample, because there are two standard deviations, right? There's the sample one, sample standard deviation, which is S, here. And then there's the population standard deviation, which is equal to sigma, right? Sigma, this guy. Okay, so they won't come right out and tell you in the problem what you're finding, right? You've got to know, you've got to be smarter, right, than the problem. Now in this particular one, they tell you right in the problem, which is really nice, that it's a sample. See that? Sample of 10. right? Which, quite frankly, is what it's going to be most of the time, especially when you have data sets. The exceptions to that are actually the probability distributions, which we work with in chapters 5, 6, 7, and 8. Those ones you assume you know the whole population because you assume it follows a certain probabilistic formula. Okay, so this is a sample, so we're going to find sample standard deviation. Instead of all this flippin' work that you don't want to have to do and all that jazz, you don't do it. You do equals stdev.s for all of that stuff. And there it is. I'm going to move it over just so I can label it. So this was sample standard deviation for all 20 observations. Done. And while I'm on the subject, I'm going to find the mean as well. The mean for all 20 equals average. I know they didn't ask for it, but I don't care. I'm just going to find it. Okay? I just wanted you to see it. And if you want to make this prettier, you can, I'm Control B. I can go to the home screen, make them centered, make it so that they have borders, whatever. You can fiddle around with that at your leisure. Okay? And then I always particularly like highlighting things so that I can keep them all separate. So this was the sample standard deviation for all 20. So that's the answer to the question they actually had. And if you've got around it, you can see it'd be 6.057, so 6.06. I don't know how many decimal places they wanted. Let's check here. So 6.06, so they want 2. You can either round that in your head, or you can right-click, Format Cell. It's going to take it a second. There it is. Click number. Say you want 2 decimal places. Diggity done. Okay, so then they want the standard deviation for the males and the females, right? Each separately. And they give you all this work and all that junk, but you don't need any of that, right? So what you're going to do is you're going to find S for males. You know what? I'm going to find the average too. Mean for males. Mean for females, because why not? I can find the average equals average of those 20 customers right there. And then I'm just going to click and drag. I move my cursor to the bottom right corner so it turns into a little plus sign, and then I drag it across. I'm going to be very gender biased here. Give them the blue and give the ladies the pink. It's terrible, I know. All right, and then I want S for males. I want S for females. And again, I know that these are S because it said sample. If it didn't, or if it implied a population, then I'd do stdev.p for population. But this is a sample, so I'm going to do S of this data set. And then I'm going to format that cell right now. Right click, format cell, number. I want 2 decimal places. And then I drag it across, and there's the females. So there's the males. And here's the females. Done. There we go. Those are what we were looking for. Right? These are the answers to the questions. The mean stuff I just threw in there to kind of be a reminder of what we already did in section 3.1. Now, just on a side note, if they did want sigma, here, insert symbol. If they wanted sigma for males or sigma for females, right? I could do that. It would just be equal to stdev.p. If you're in old school, it's stdevp, right? For population. I have the newer version, not the newest version, unfortunately. I don't get that for a little while, but newer versions have it like this, and then you can drag across. And again, I can highlight those, format them, and make it so there's only a couple decimal places. There you go. But of course, this wasn't appropriate here because it wasn't just 10 males that as a population, that those 10 males were actually a sample. Okay, and you notice that S is a little bit bigger. That's because, of course, when you only have a sample, you don't know as much. So you have to allow for a little bit more wiggle room, a little bit more give or take. And that's why you divide by n-1 in the bottom of the formula for standard deviation. Right there, the 10-1 or the 20-1 up above. Okay. Now, of course, you don't actually have to do these calculations on an exam a lot of the times. What you'll be doing is, like, I'll do something like give you S. Like, I'll tell you S is 5.68, but then I'll ask you for the variance, and you have to find it, right? And we all remember, hopefully, that the variance is equal to that guy squared. And that you can do. Oopsie, I think I did that wrong. I don't know why it's not liking me. Oh, it's got so many decimals. That's why. All right, so let's see. Let's do 2. Right? Like that. That you can do with just a regular calculator. You don't need Excel or anything. I'm just squaring it. Or better yet, I could give you variance and ask you for S. That would be taking the square root, right? Or I could give you the standard deviation and say, hey, was this sigma or was this S? And you'd say this was S because it was from a sample. Stuff like that. Right? Okay, then I want to show you how to do this in Statcrunch as well. So let me go to Statcrunch because it's super simple. You just go to Stat, Summary Statistics, Columns. I'll do males next. And you really don't need most of this stuff. I'll just throw in, well, I'll leave the variance in. Why not? Variance, standard deviation, click, 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 click. All right, down at the bottom, do you see these ones? Unadjusted standard deviation. I'm going to throw that one in there just for the fun of it so you can see. Okay, see it? Let me pull up the Excel spreadsheet so you can see. 5.68, there's your standard deviation. Unadjusted standard deviation is 5.39. See that? It's sigma, right? So when you're doing a problem, you have to read into it and go, oh, this is a population. I need the unadjusted one. That's sigma. That's this one. Or, no, this was a sample. I need standard deviation right there. See it? And this variance is that standard deviation squared. If you wanted the unadjusted variance, let me go back here. That's this guy right here. That's sigma squared, right? So there's S squared, S, sigma, and sigma squared, right? And Statcrunch can give you all of them all in one fell swoop, which kind of makes it nice, right? And if you wanted, you could copy and paste in here, no problem. Okay, then you could do it again for the females. So I could go to, I'll just do it again up here. Data, stat, summary stat, columns, females, next. Turn off all this junk. I'll leave that on. And again, if you we're interested in sigma, they're down there. We actually don't want it for this problem, so I'm not going to bother finding it. There it is, 5.58. And now to do both of them, the simplest thing is just to kind of go up here and make a column that's both of them. Let's put the males. So I'm going to highlight those, copy, Control V, paste. And then I'm going to highlight these, Control C, copy. Go down here, Control V, paste. There I've got all of them together. Stat, summary stat, columns, both. And then again, we don't need all this junk. I'll leave the mean in there for fun. Let's turn these all off. Okay, I want the standard deviation. I don't know. I'll throw the variance in there for fun. Calculate. There it is, 6.06. See it right there? Done. You can copy, and you can paste right back into Excel if you so desired. Right? This was males. This is both. Right? That kind of thing. I can even highlight it. I'll make it yellow. There we go. All right, so now you know how to use Statcrunch and to use Excel. Now, the one thing you might have noticed, and again, was that the standard deviation was larger for the group than it was for each individual, which makes sense because, look, if you're going to compare males, which are all similar, and females, which are all similar, then you're going to get smaller spreads, right? Because the guys are all kind of alike and the girls are all kind of alike. And then when you do it all together, you can see you're comparing the shorter boys, these are young kids, shorter boys with taller girls. And so you're going to get a larger spread. It's like including the seniors and the freshmen together. You're going to get a huge spread when you put them all together. But if you just looked at each group individually, you'd get smaller spreads for each group. Okay? All right, so you've learned how to find standard deviation with Excel and with Statcrunch. One last thing to keep in mind is that you are never doing this stuff by hand. Even on your tests, you're not doing it by hand. I'm usually just giving you outputs so that you can ignore a lot of this stuff that they have doing it by hand. If you're stuck, go look for some videos or ask me some questions with Ask My Instructor, because you're not supposed to be doing this by hand. You're supposed to use Excel or Statcrunch, one of the two, and you could literally be done with this problem in like 30 seconds. As long as you know what you're supposed to do with either Statcrunch or Excel, it shouldn't take even longer than a minute. All right, see you later.